Welcome, ladies and gentlemen, for another video with Dyson Sphere. So, there are four fundamental forces which keep the Earth, the solar system, and even the whole universe together without collapsing. So, what are those four fundamental forces? So, in this video, we're going to learn about these forces from the weakest to the strongest force. So, we're going to start off with gravity. Gravity is the weakest of all fundamental forces. It is the force that keeps planets, stars, and the universe from splitting apart and going their own ways. Basically, the greater the mass of an object, the greater the force of gravity. Yeah. So, practically everybody knows gravity, thing which keeps you from floating away into space and attaching you to Earth. Not exactly attached, but keeping you on the Earth without, of course, being attached. Okay, so that is the first fundamental force. This is the weakest one, gravity. Next is electromagnetism. Electricity and magnetism are two sides of the same coin. They depend on each other because if one doesn't exist, the other one will also not. When electrons flow through things such as copper wires, it of course passes electricity but also creates a magnetic fields, and vice versa. Magnetic fields can also influence electric paths. So this is electromagnetism. The second weakest is basically that electricity and magnetism are corresponding forces. Without one, another won't exist. Yeah. So next is the weak nuclear force. So the weak nuclear force is much more quantum than the previous forces. So while the gravity works more in a larger spectrum, that means where we can see stuff in very large areas like planets, stars, gravity will mainly work there. It's gravity's domain. While electromagnetism's domain is the smallest stuff, things we can see, and even smaller. Atoms are also under electromagnetism's domain, while the weak nuclear and the strong nuclear force are also work in the same small domain, but even smaller. So the weak nuclear force is much more quantum than the previous forces. This force lets nuclear fission, fusion, and beta decay to happen. So here's the process on how it happens. Take an atom's nucleus, such as copper-60, an isotope of copper with more nucleuses than a normal copper atom. Yeah, so okay, in the nucleus, sometimes an excess neutron might convert into protons. This is known as beta decay. What happens is that a particle known as a W boson will change a down quark in the neutron into an up quark, converting the neutron into a proton. The W boson will decay into an electron and an electron neutrino. Another particle called a Z boson acts as a mediator for this process. Due to beta decay, nuclear fission and nuclear fusion can occur, leading for stars to work and create light because nuclear fusion happens, of course, and also nukes. Yeah, without these forces, nukes cannot exist, and of course, stars and their light, and even life at all. So next, it's the strong nuclear force, the strongest of them all, and the last one of this video. So strong nuclear force is the strongest but still also quantum fundamental force. Normally atoms should not exist because protons will push each other off because of their equal charge. But this force is what keeps atoms' nuclei together. So take any nuclei of an atom and this force will be happening inside of it. So take two protons with two up quarks and one down quark. Every proton has one. Okay, so this structure of quarks is being held by another force, which is completely different from the strong nuclear force. The strong force, which I'll cover in a different video. It is different. Do not get confused between them. One is for the strong force is for to what do we call them? To just keep the structures of the quarks together to form these nucleons. While the strong nuclear force's job is to keep the nucleuses together. So sometimes while the strong force is happening, a quark might stretch too far out from its nucleon's area. The quark will unstretch back to its place, but another pair of that quark and its corresponding anti-quark is created, called as a pion meson. This pion will move to another nucleon, making the other nucleon attract to the first nucleon. It's basically a ping pong game between both the nucleons, with the ball being the pion. And for each bounce of the ball, these two nucleons get closer, the protons in this example. So the strong nuclear force is 100 times stronger than the weak nuclear force, a million times stronger than the electromagnetic force, and 10 to the power of 38 times stronger than gravity. Yes, strong nuclear force is practically the most powerful force in all of the universe. Yeah. So this for today about the 4 fundamental forces which keeps the universe together. So bye.